Hi everybody, in this video we're going to go back over the p-value and the t-test and really focus on what these are telling you and how you can use them, and then at the end of the video I'll show you how to calculate them in Excel. So we're first going to start with the p-value. If you look up what the p-value is, or you ask several different statisticians about what the p-value is, you'll get a bunch of different answers. And so I have tried to read some. P-values are not my special gift, which is why I kind of flubbed explaining them to begin with. But I've been reading more about them, and so I'm hoping that this explanation will make more sense to you guys than the previous one. So let's try this. So the p-value is the likelihood of seeing your data if the null hypothesis, which is, remember, the no effect hypothesis, is true. So what is the likelihood that you will see the data that you actually got if the null hypothesis is true? Okay, so if our p-value is large, then it is likely to see our data if the null is true. In that case, we're happy with the null. We feel like it is likely to explain the data that we got, and so we will accept the null hypothesis. Alrighty, if our p-value is small, then we are unlikely to see our data if the null is true. Since we actually did see our data, then that suggests to us that the null may not be true, and so then we reject the null hypothesis. I feel like I'm writing off the edge. Hang on, let me move the camera. Oopsie. Okay, so p-value is the likelihood that you see the data that you actually observed in lab if the null or no effect hypothesis is true. So if the p-value is big, that means that we are likely to see what we really saw if the null is true. So then we feel like the null explains what we saw, and we keep the null. We accept the null or no effect hypothesis. If the p-value is small, that means that we are unlikely to see the data that we saw if the null hypothesis is true, which means the null hypothesis does not do a good job explaining what we saw, does not do a good job explaining the relationship between the independent variable and the dependent variable. So in that case, we will reject the null hypothesis and accept our alternative hypothesis. So then the question is, what does it mean to be large or small? So you guys may remember the significance level from when we went over p-values and t-tests before. So a small p-value, scientists have decided, is going to be one that is 0.05 or less. So if your p-value is greater than 0.05, then it is large enough that you accept the null. If your p-value is less than or equal to 0.05, then you feel like the null hypothesis is unlikely to explain the relationship between the independent and the dependent variable, and so you reject the null hypothesis.